Okay.
Go.
So we have each other.
So,
Yeah.
I think this is just kind of complicating things because it's really good drawing, but you're looking at it kind of too close on each individual step. This is what you.
Okay.
You have your two stages. You have meiosis 1, which is right here, and meiosis 2, right there. If this question is asking about meiosis, you start out with one cell.
But this is before replication. This is before we're at 46. This is when we're at 23.
Well, so what happens is, this is what happens. So you start with 46 chromosomes. You double them. So they all get sister chromatids. Every single one of them gets sister chromatids. So technically here, at the end of this stage, that cell before it splits will have 92 chromosomes. If you count the sister chromatids as separate. But technically, they only have 46, and sister chromatids aren't individual chromosomes. You'll have 46 chromosomes here. They'll divide.
This is before replication.
This is before replication, 46.
And then after replication, we'll have 92.
You'll still have 46 chromosomes, but your number is going to double for how many sister chromatids you have. You're going to go from 46, which is not even 46, it's just 46 chromosomes, to 92 sister chromatids. This is how your chromosomes look before the replication, just pairs, boom, boom. This is what they look afterwards and after the division and replication.
So do we have 23 homologous pairs?
Yes, 23 homologous
Okay, so
pairs.
let's write this down.
So, chimpanzees, you just bump it up to 48. So that's just easier to do.
So that'd be 96
Yeah.
down to 24.
Okay, so prior to DNA.
Chromosomes,
No, that's next to it.
23 homologous pairs, and I don't know exactly what they mean.
So I'm gonna go TN for total number.
Yeah.
We have 46.
So 46. No, 48. Because you're in
Oh yeah,
the
we're in 48. We're in it's 48. And then for
total number is 48.
homologous, I'm just gonna go H.
Homologous.
Homologous, you keep saying that.
Is that how you say it?
Homologous. It's okay though. I still get what you mean.
Why did we just use those stuff?
So then there's 24.
Yeah.
Of homologous. So you said homologous too.
I said I never said. I didn't even say.
Sister chromatids, we have 0.
At the top, before replication,
Yeah.
Okay, so then beginning of metaphase 1.
Sister metaphase 1, that's where
That's why you would have 24. No.
this is going to be this,
Yeah, you'd
right
have.
in this step before you split off into those two. Because telophase is when you finally go
Yeah.
into two separate cells.
So it's
So there you're going to be doubling a few things. So chromosomes will technically have 46 chromosomes, but you'll have 90 or 48 chromosomes.
In this one, it'll be 40.
And then you should have 90. No,
96.
96. You should have 96.
That was rough.
sister chromosomes.
Numbers are hard. I
Go on,
understand.
babe.
So we'll have 48. We'll still have 48.
It'll be 48
Chromosomes.
chromosomes
How many?
of
Homologous.
There you go.
That's
You got it.
bad.
Or you should have 24 homologous pairs.
And it would be 24 sister chromosomes as well.
Well, you have 9. It depends on how you define it. Would you define it as the pairs, or would you define it as each separate sister chromatin?
Each
It would be
separate.
each separate.
If
Each
each separate, it'd be
separate.
the 96.
Okay.
So 96.
96. At the end of
Oh, that's-
telophase 1, then
well,
that would.
oh, yeah.
That's before telophase 1.
So then at telophase 1,
It would be so you'd have 24 then.
so in each cell, so in one cell, we would have
So it'd be like this.
24
So just
homologs.
change these numbers up.
No, we'd have half of 24, wouldn't we?
No, we'd have
No,
24.
They take each one of these.
I don't think I've shown up on camera yet. But yeah.
It's never going
I
to
think
be.
it's here.
You wouldn't have any homologous pairs.
Okay, so but for total number of chromosomes.
Total number of chromosomes, 24.
Yeah.
Total sister
It'd be
chromatids,
48.
48.
Yeah.
Homologs 0,
And on the, yeah.
and sister chromatids,
And the next would
12?
be-
End of telophase.
oh, 46, 48.
Yeah, it's never
48.
going to be half the transport.
End of telophase 2, really similar numbers. You're going to have 24 chromosomes, but you're going to have 0 pairs and 0
Zero
sister
sister.
chromosomes.
Yep.
So we're gonna have 24 chromosomes, 0 pairs, and 0 sister chromatids.
Yeah.
After
Then after
fertilization,
fertilization,
we're back to everything,
Yeah.
back to normal, which was
which
prior
would
to
be
DNA, prior to
Yeah.
DNA replication.
48, 24, if it's 0 sister
48, yeah, 48, 24.
We're assuming it's
24.
his chimps, right?
They still have.
Oops, that should be 48.
Yeah.
About
They do.
48.
So do you.
that.
So do you, for that matter.
What?
Yeah.
We all have genetics.
Okay,
You're a mutant.
Oh!
that was a little rough, for me anyways. Okay,
Got through it though.
you guys have done number 5. Number 5 is really easy. It's
We're gonna
just
do a
Punnett
Punnett square. Yeah.
Punnett square, yeah.
Wait.
Yeah. Can we just make sure we get it in the video?
I'll take the. Is it started enough?
Yeah.
I was gonna take a little bit. Come.
I'll do this one, guys.
Can you see enough of you in this one? Is that a good
Don't hold it
angle?
like that.
What do you mean don't hold it like? Hold up. No, that's not. Nope. Going down.
Bam.
All right, that's good. This Punnett square. This one.
Okay, so what is the combination?
Tall and
Yeah, tall, dominant.
Yeah, but what is
tall
a cross between a heterozygous
Tall, piece of
So
that.
big T, little T,
and a dwarf plant?
little T.
Big T, little T, little T,
Oh, that's easy, bro.
big T, little T, little T, little T. Then it wants,
This is easy. Wait until.
what does it want?
It's asking just for cross.
Yeah, but then what does the question say?
And the cross predicted genotype and phenotype ratios of the.
So genotype, so
It's gonna be
T would be
1 to 1?
1/16? No, 2/16. Right?
The genotype
The
would be
genotype?
1/2.
It'd just be 1/2.
What am I looking at?
I don't know.
Maybe it's the next question.
Half for
Or
heterozygotes,
if you
half for
want to, you can do
recessive.
2/4 and 2/4.
T,
Yeah.
1/2,
Half are gonna be the dwarf and half are gonna be
tall, dwarf.
Yep.
Well, I overcomplicated that.
Next question, number 6.
This was the one I was thinking.
Let's
Okay,
go
so we
for
got
it.
that one, everybody got that one, that was pretty easy.
Yeah.
So this is a cross of 2 traits.
T-shirts, what are they?
It's
Smooth.
smooth, constricted, and yellow and green.
Restricted, and then yellow and green.
Yes.
And what are the crosses?
So constricted. We can do 2.
Constricted in what? What color?
What's the color with this one?
Constricted.
And it's
and it's
heterozygous color.
heterozygous C color, so that means it's gonna end up being yellow.
Okay,
Yeah.
and what's the other one?
Heterozygous for both.
Heterozygous for both?
Yeah.
The good news is though that these traits are sorted independently, so you can do 2 separate Punnett squares since they don't affect each other.
Okay.
Yeah.
I don't know what you just said.
So what you do is,
I did it together.
you can do it together, but it's just feels
A
complicated.
lot of-
So all you have to do.
Oh,
is
maybe I
just like
didn't.
that, you do little less, big S, little less. With that, and then the next one, you can do it. If those heterozygous, both of those can be 50/50. So it'll look like that. So since they're independent, we don't need to worry about one of them affecting the other. So, so for the first one, 50% of the offspring will be,
So this is just phenotype that we're predicting.
yeah, the phenotypes will be
50% will be
smooth,
Smooth.
finicky, constricted, and then
50%.
And that's gonna be, but you have to.
Then
So
you can do 2 separate ones.
25.
The genotype and the phenotype of the first one are gonna be the same.
yeah.
Whereas this one's gonna be one.
But we don't need genotype in this one, we just need phenotype.
Oh. No.
So 25% will be
The little one, isn't it?
No.
Be yellow.
25% is gonna be green.
yellow,
green.
Green. Because green is the.
Oh,
Yeah,
right.
green is the small. And then 75 is the yellow.
I was thinking heterozygous.
Yeah.
Heterozygous. 75%
We only need to know the.
will be
Yellow.
yellow. Perfect.
Oh, just a few.
That's it.
Oh, we got one more guys to do this. Push through.
Are you serious?
Jeez, what the heck?
Should probably start.
The cross
This one is hard though.
Yeah.
What is the?
No, it's not hard, it just takes a lot of
proportion
time.
the
I'm gonna go get some
offspring
water.
expected? How did we do this with?
So that can close.
Suppose you perform the following.
What proportion of the offspring?
It says again.
We don't know.
Assume all the genes involved. Oh, so we need to like, it's one of these like,
Oh, this is a
what's that keyword?
probability.
Probability.
This is we find them. We would do that because it's independent assortment. But then based on the probability, we would have to add them together by doing.
I don't know how to do that.
probability
Wait,
rules.
do we?
I don't remember how to do it
actually
either. This one. I can look it up.
Okay, Mary, you got this one.
change them?
Are you? This was by far my worst exam because
The first one.
It's a lot of the math
I was
part.
totally fine until I got the probability and I just
181.
screwed on it.
No, for
Not for 375.
That's not too bad.
I don't remember.
Is this mine?
that's too small.
This one's fine.
Variation.
So in this one, it should also be independent. So I'm thinking that we could just do it the same way. You could do
No,
the
you
really,
can do it the same way.
you could do the really big Punnett square if you wanted to.
No.
Some people like it, but this one it'd be the same way. And
Really,
it's like
setting
that.
it up
Just do all
isn't
the
going to be hard.
You might have borrow this.
It's
Go for
just, this is Omar, by the way. But setting it up, you would set it up the same way. It's just based on the path that we get. We have to add it up.
Well, the portion would have A, B, C, D. That's how you do it. You go through it and you go. First A.
Not drop.
It's not mine.
Yeah, you better not drop it.
Reading in on our suit.
And not yet. I'm
Oh,
looking up
that's another
something.
class.
There's the first one.
So this is 50% of this one.
Vacation radius.
So basically, what you would do is, you know how we set it up on this one?
As multiplication.
It is multiplication.
Yeah.
Do you remember the rule? It's just straight multiplication of all of it.
Of like the fraction though, right?
So basically what you do is just you do them separately because it's independent assortment. And basically whatever the probability is of this, you multiply by that probability of it being more than that.
Oh, by this one? Oh,
And by that
gotcha.
one. Provided we're using the right.
All right, bring it right all huddled.
Oh yeah, they get it. Yeah, we're good. We're all-
Are you good?
Oh.
That genotype will not be my bad.
I don't think you cancel, I think you just, there we go.
Yeah, yeah, okay, that's what I'm looking
So,
at.
yeah, 25%, 25%, 25%, and then 50%.
This is 25 as well?
Wait, so what is the question?
So what proportion of the offspring is expected to have
That
big A, little
genotype.
A, big
What?
B, little B, little C, little C,
I
big D,
just
big
thought
D,
it was
yeah, I forgot.
Last semester, so.
16, 32, 64. So according to straight multiplication, it's 164. So that would be, that's like a 6% chance? No, that's a little low. I mean, that's really high. That's extremely high. Math is not my thing, guys.
Straight multiplication.
But if it's just straight multiplication, which I really hope it is, then it would just, it's a 1 in 64 chance to have.
Yeah, there's just what's your probability. So you have probability of 1 times probability of 7 times probability of 3 times probability of 4. It's almost kind of like the
Yo, hold
oil
on,
frequencies
hold
and stuff later on.
on. Why am I doing a 4? Is it a half? Oh, it is a 4. Because there are two.
1/4.
No, then it should be 3 1/4.
Oh my
So we have
goodness.
1/2.
Yeah, 1
So
half,
it's
1/4, 1/4, 1/4.
0.25 times 0.25 times 0.25.
Don't give me that. No, I like
times
this better.
0.5 equals 0.0078.
32.
0.0078% that they'll have that genotype.
Yep.
Bam.
Nice.
28, there we go. Which is that. So now do 1 divided by 128. So I make sure that the math is right.
It should be the same.
It's just, That is hard.
That
It
was
should
not
be.
very long.
Number 5.
Yeah, something.
Alright, good.
Cool.
So it says independent assortment, is that the same just as independent events?
Yeah.
That just means that one doesn't affect the other. So they're gonna be
Which is good.
assorted separately, so these things are on, sorry.
That's lucky
Like
that they're.
separate chromosomes, stuff like that, so.
I think it's unlikely that it's like that. But.
Where did we get 1/4 from?
Which one?
Because you got a
For-
25% of
Because
that.
if you look
happening.
at the question, do you have the
Mhm.
question right there? It says, what's the probability of having those
Mhm.
genotypes? So
You're
what
kidding
kind of
me.
bees does it want?
It wants
that.
big B, small b.
Like that.
So
Big
So
bees,
that's
small bee is right there.
Right.
so that's like 1/2.
that's 1/4, because you only got one of them.
Oh, there's only one of them. But for A, there's two of
There's
them.
two, which is
Which is
50%.
50%.
Oh, so it's just because
So
it
the
said
one
1/2.
Yeah,
And
Oh,
this is
that's
only
the 1/2.
1/4.
yeah,
Okay.
and the rest
This
of
is
them are
1/4, and that is 1/4.
Okay.
Then you both come together.
Small c, small c.
Dude, I get this.
Good. It's
We're all
not so
good?
hard.
You can learn this in 3 days. Sure, the foundation science class, this takes you like 2 weeks.
We learned this in 20 minutes.
Yeah, actually.
Why isn't that one big B, small b? At the bottom corner?
Which one?
Yeah,
Oh, yeah,
that,
you're
that
right.
should be big B, small b though.
Hey, fool.
Alex, I messed it up. Sorry.
So then this should be 50.
So it is-
Yeah, it would be.
You were right.
So it is-
You got it right.
Yeah.
Yeah,
Jagaloons.
1 divided by 64 is 0.016.
0.016.
Which is 160.
There we go.
0.016%
60,
or
yeah.
1/64.
Yeah, Jagaloon.
Okay.
Same thing when I did 1.
Good catch, Miriam. I just saved us some stuff later.
Yeah, there's some points.
All right. I practiced
Is
it.
it even worth points?
I don't know.
We good?
When we hand it in, maybe.
Should I end the broadcast now?
I think we're good. If that's all we need to do.
Yeah.